Oh, oh yeah, I forgot my mic doesn't have lights on when it's turned on. Hey everybody, how's it going? Sorry, that was me coughing. I'm kind of sick. Oh my god, I forgot I put this in. You know what? Yeah, I'll leave this in my homework. What the? When was this? Oh, it's beautiful. I kind of want to draw. I think there's one little guy I might draw today, but we do have to do some wizarding, some alchemy. Well, okay. I think physics is like alchemy, and math is like the transformation circles that you have to like learn, you know? Like you can't do alchemy without the transformation circles. You gotta like learn how to do the transformation circles like separately. Anyway, so the main thing we're doing is theorems. So we're gonna be doing the first shifting theorem for Laplace transforms, the second shifting theorem, and the sifting theorem, which is not shifting theorem. That's just about the delta function. What are we speedrunning? We're not really speedrunning anything. Oh, you heard run. I said runes. like I don't know. Like magic. The runes. I could try and speedrun these. I don't think I'm good enough to speedrun these yet. I'm a little like slow on the uptake. Wizard? Yeah, exactly. I'm a little slow on the uptake for some of my transforms right now. I keep getting the first and second shifting theorems mixed up, and ideally, you know, I don't want to do that because they're like the same thing, but they're also different. It just depends on if you're doing the transform before or after. So, yeah, we're just gonna do some easy ones right now. We want to find the Laplace transform of e to the negative 5t plus 1 over the square root, so square root of 2 times t to the 1/2. This is awful. This is so awful. I'm gonna have to use the t to the 1/2, I think. But we can do... So the e to the negative 5t plus 1, that's gonna equal... Because we want that negative 5t, that's gonna give us a shift. That's our first shifting theorem. We're multiplying the function by e to the negative as. So we'll do negative e to the 5t. Actually, let's pull them out first. So I'm going to pull out just an e to the 1 over square root of 2. That's the first thing I'll do. And then we have a Laplace of e to the negative 5t times 1 over t to the 1/2. Do I know the shift of t to the 1/2? No. I could do the convolution of these two, but I really don't need to do that. Lurks with intent. So if we want to get rid of that e to the negative 5t, that's gonna shift it to be, it's gonna be e over square root of 2 Laplace of, I guess, t to the negative 1/2, we can do that. But we're gonna replace s with s plus 5. Because it's going to be minus... Wait, is it s plus 5 or s minus 5? Wait a second. Important. I don't want to do all of these wrong. The thing is, it's like, so it's e to the negative as. And a is, I think it's minus 5. Because we're shifting it over to the right, usually. I think that's how we do that. Let me check my wizarding book. My tomb. Oh god. Oh, I picked it up backwards. That is not good for my shoulder. This is why I have to have my thing. Well, here it goes, right at the top. What were we doing today? Oh, we were doing convolution today. I love that they named I don't know if my friend might have been gaslighting us. He was like, guys, so you know why they named this thing? It's called a convolution. It's like when you... It's an operation you do to like two functions. He was like, yeah, so they named it this because it's really convoluted. And I'm like, I don't know enough to disprove you, but that seems like you could be gaslighting us. Okay, let's see. So e to the f, Laplace of ft times e to the at. So yeah, we have Laplace of ft times e to the at. Okay, this is a positive at. Wait, is it though? Wait, e to the negative s minus a t. Yeah, so a, yeah, a. So it will be, yeah, minus 5. Okay, cool. No, wait, plus 5, plus 5, plus 5, plus 5, plus 5. Ugh, it's just memorization. Okay. Yeah, because e to the at turns into f, big F of s minus a. Cool. And then I just have to figure out the t to the negative 1/2. We did that before. That was in this other problem set. It was like the first one. Nope, the second one. Wait, yeah. Can I just use this result? Oh no. Oh, I forgot I like got this wrong. Also, by the way. I like forgot. Oh no, it's 2s. No, we're chilling. I don't know if I got this wrong. I think I have my bounds wrong. I don't think it's for some reason it's like pi over 2 instead of that. Which would that instead of 2 pi? It's like over. It's like this. Like over 8 or something. I'm gonna leave that one because that's. I mean, you just have to then do Laplace of e to the negative 1/2 and then just change it out. So that's fine. I'm gonna move this to the next line actually. Let's be nice to the grader. There we go. S plus 5. Sick. Alright. I wrote A again. Oh god, it's one of those days. I'm just gonna put a little star here that I have to do that. Alright. So now we have Laplace of 5t minus 3 u3. So that's the unit step function. This is just like we say there's nothing happening, and then at 3 we're gonna get this 5t minus 3. So something that's like this. I don't know. It's probably steeper than that. Something like that. But its intercept is 3, so it kind of makes it work out that it's just like literally just moving it over. So this is the second shifting theorem. So if we want to get the Laplace of this, the Laplace of u3t is e to the negative 3t times the Laplace of 5t minus 3. And we need to change t to t minus 3. Wait, but at t equals 3, wouldn't it be would it be 12? Wait, let me think. Maybe this unit step function is just like not super nice. Generally, the reason we do a unit step function is to represent piecewise functions. So I think it's discontinuous. It can be, like, it doesn't matter for the Laplace because it's an integral, so we can break it up. As long as it's not infinitely discontinuous. But like, the reason we do that is so like if we shift sign over, then our sign will be like also shifted instead of like if we start it and it just starts like up here or something. So you technically don't actually have to shift this by 3. But I think the thing is here, we need to, this might be like, we might need to pull out. This might have to be multiplied by, because I want this, I think I want something t minus 3, but I don't know. No yet. I'll have to look. Let me look at the second shifting theorem. Real quick. Second shifting theorem is, okay. e to the negative as times our Laplace function, like our in-between function, equals e to the negative s times the Laplace of ft equals ua of t f of t minus a. Okay, yeah, so it is f of t minus a. So this t minus t thing, this does not happen. This is it's a different, like, so this e minus 3t is going to happen. But we need to format the f. So our f in this case is 5t minus 3. So it's going to be f of, it's like f of t minus 3 instead. We need to get that. So f of t equals 5t minus 3. F of t minus 3 equals 5t minus 15 minus 3 equals 5t minus 18? Question mark? So we have to get that, but like that's not really gonna jive very well. Let me see how we did it. Okay, so inverting this with a Laplace is a lot easier. Doing a Laplace inverse for this. Or I know how to do it, I guess is my... Doing the Laplace of a unit, if it's just a unit step, then the unit step turns into... Oh, it's just the unit step turns into, I guess, e to the negative 4s? Or sorry, not negative, negative as? Wait. If we have like 20 times that, then... What? What was I doing here? Yeah, it turns into negative 4. Oh, because it's 1. So it is, yeah, so... That's just the, no, that is the Laplace of the unit step function. So... Okay. We have the Laplace... So it's e to the negative 3s, not t, also. E to the negative 3s times the Laplace of... Let's see, it's u to the or t. We didn't do anything to change the... I guess it might just be the Laplace of, I guess, 5t minus 3. But it's just the e to the negative 3s changes the whole thing. I mean, I guess I could just like do it out and prove to myself that's right or wrong, but I don't like that. I'll do one from the book after this just to see if it's right. So it'd be 5 times the Laplace of t minus 3, I guess, like the Laplace of 3, which is just going to be the Laplace of... I think we might have to do something, because I remember this, you have to, like, massage that, I guess. This would be, let's see, 5 times 1 factorial over s squared minus 3 times 0 factorial over s. So that'll equal e to the negative 3s times 5 over s squared minus 3 over s. Factor out whatever. Okay, I'm gonna grab the book real quick because I feel like this is not correct. Or like not entirely correct. That's why we do stuff. Okay, this is Laplace transforms. I wish it had intersections, but this book is not cool enough to have intersections that I can jump to. I think this is 10 point... oh, here we go. 10.6? Nope, 10.7. That's the second shifting theorem. I want the first one. Wait, what? Oh, I see. Wait, no, I want the second one. What am I talking about? Here we go. Determine the Laplace transform of... Okay, I just want to find one that gives like a t. Okay, t What about... Yeah, so... Okay. Like, for example, this one. This is number 9 from 10.7. I'm using good and Anna, and it's like one of the... So like 10.79. This is e to the t minus 4 times t minus 4 cubed, unit step function of 4t. And so if we take the Laplace of this, then we take this out, so that becomes an e to the negative 4s, and we change all of the t's to, or the t minus 4s to t's, I guess. I guess we change t minus 4 goes to t. So I guess like t equals t plus 4. Yeah, maybe. So then you get Laplace of e to the t cubed. And then this e to the t is the other shifting. So that's going to equal e to the negative 4s Laplace, and e to the t is going to shift this function by, this will be 3 factorial over t to the 4th, but our t to the 4th is going to be turned into t equals t goes to t minus 1, because this is e to the negative a t. Maybe? It's so confusing for no reason. They're so similar because they are like the same thing, is the thing. Let's see, e to the at, yeah. So t is gonna turn into something that's affected. It's an s. Sorry. That's why it's confusing. Okay, let's see if that's right. Because if it's not right, then we gotta figure something out. That's the index. Append it. Answers to odd numbers. 10 point. What did I say this was? 10.7? 9. Okay. Was this 9? 6 e to the negative 4s, s minus 1 to the 4th. Okay, s minus 1 to the 4th. Oh, and 6 is 3 factorial. Whew. Whew. Okay, we got it. Yeah, okay. So if we see an e... Okay, in a Laplace, if we see an e to the s, e to the a, negative e to the a, e to the negative as in Laplace, that's gonna go, we pull that out, pull out to s turns to s minus a. Alright, we don't do anything other than that. And then if you have a unit step function, a, t, in a Laplace, you pull out to e to the minus as, and change t to t plus a, I guess? Okay, let's try that again then. We are definitely gonna have to massage this. Or maybe we don't. I don't know. Maybe we just have to plug stuff in, because maybe that's the smart thing to do. But let us tackle. I will get rid of this, but we can leave the... Sorry, I had to sneeze. Ugh. Okay. We see a unit step function. Okay, first, we lock in e to the negative 3s. Okay, we get that out of there. Now, we have a Laplace of negative 5 minus 3. That exists, and we have to do something to it. And t turns into t plus 3? Perchance? Okay. Let's see if I can find one that's a little bit better example of like the harder version of this. Because this is like, it's that one that we saw wasn't bad. Oh wait, maybe I can actually find an example that they do, and then I can look at that, and then we can be happy, and we can run around in the fields. Man, they're just giving like easy ones. I really should just do some differential equations, because that would probably be the best way to practice it. Okay, wait, unit step function, here we go. Oh, here we go. I'm gonna pop over to this dimension. There we go. Okay, so make a function, the step function, easy. That's not really what we care about. Okay, here's the second shifting theorem. What? Why did it throw me to non-defective coefficient matrix? Get out of here, man. Get me back there. I was having so much fun. Where is it? Okay, here we go. Second shifting theorem. This is proving it, it's fine. Yeah, so we say UA f of t equals e to the as f of t plus a. But I don't know if we just change, I guess we just plug in t plus a, like that's what I was doing. Okay, so the unit step function is t minus 1. U of t, so we turn on t minus 1 at t, and we turn off t minus 2 at... What? That's a what? Okay, I think they factored this. It's a little more complicated than that, but it's fine. If we let g of t equals t... What? Wait, what the frick? What the heck are they doing here? Oh, I see. Oh, I see. They just changed it to plus like 2. And they pulled out the 1 minus s squared. Yeah, okay. So yeah, we're saying we're shifting this by -1, and then we're, I guess, adding 1, and then... Wow, that's a really bad way of writing it, huh? Okay, to determine L of f, we first express f in terms of whatever, sure. If we let g of t equals e to the negative t minus 1, then... okay. Then 1 plus u2 of g minus 2. Okay, so t minus 2 is our variable there. Is that from... Okay, wow, they really just... They just tell you it. Okay, let's see if we can figure this out. 1 plus... So, are they doing partial fraction decon? No. The 1 should be... So they're doing the... They're shifting by this -2 here. But they're also like... Ooh, I don't know why they're doing... They're like subtracting they're subtracting that shift there too? Why are they doing that to the 1? Why aren't they like doing the linearity of transforms? I agree with this part, the s plus 1, because we're gonna add... Oh no, I don't... That's, Let me go with 1 over s, so they immediately combine it into the fraction. So I guess they immediately combine it into the fraction with the other part of the unit function Laplace bit. When it comes 1 over s. But this is like... Oh, you're saying they get e to the negative 2s over s? Where's that coming from? If it was e to the negative 2s over s, we'd have to get... This is a awful way of notating it. Okay, let me see if any of these are better. Jesus Christ. Okay, sine is fine. Ugh. Okay, Laplace of sine 2t is, yeah, 2 over s squared plus 4. I agree with that. Consequently, 2 e to the negative s equals a to the Sure, e to the negative s times... Okay, this is Laplace inverse. These are easier. I mostly care about the Laplaces. This one is weird. Okay, let's see if we can do this one, actually. Let's see if we can do this one. Because I feel like if I can step through it and I can kind of like do it the linearity way. So this is example 10.7.4. Alright, so we have, let's write it as a unit step function. So from 0 to 2, it's just going to be 1. So we say f of t, and like u of 0 of t equals 1. And then we turn off 1 at 2, so 2 of t. And then we turn on e to the negative t minus 2 at u of 2, and that just stays forever. So our whole function is going to be negative u of t, u2 of t, plus e to the negative t minus that times u2 of t. So what they say is this equals 1 minus u2 of t. Oh, it is 1. I lied. That's not a 0. Wait, but u of 0 is 0. No, it's not. It's just 1. Okay, there we go. Getting somewhere. Yeah, they say 1 minus that, and then that times that. Cool. So that is, they factor out, oh, I see. They factor the 1 into it. Okay, so I would rather do it like this. Okay, I'm gonna leave this note somewhere, not here. So I'm gonna factor it into 3 Laplaces because that makes a little more sense to me. So we have Laplace of 1, then we have minus the Laplace of u2 of t, and then plus the Laplace of e to the negative t minus 2 u2 of t. Okay, so we can do the easy one first. This one's gonna be 1 over s. This, well, I guess like 0 factorial over s. Damie, can you do some freaky math? I feel like this is kind of freaky. I mean, like freaky, like fun. This will be negative e to the negative 2s over s. Oh, I see what you were saying. You're so right. Me when you know Laplace better than I do and you've done it once. We e to the negative 2s. And I think we just plug in t plus 2. So then this would be e to the, I think that's what makes the most sense. E to the negative t then. And that equals 1 minus e to the negative 2s over s plus e to the negative 2s times 1 over s plus 1. Yeah, it does equal that. Okay. I'm getting it. It's soaking into my brain. I feel like I just need to do more differential equations because you know, you gotta like that's how you really grind the transforms. But okay, so this one, yeah. So we do sub in t equals t plus 3. So this is gonna be 5t plus 15 minus 3. And that'll be e to the negative 3s. Oh, I'll write it on the next line. A little big. Oh, did everybody hear my email sound? 3s times 5 Laplace of t. Whoops. Oh my god, there we go. The brackets were winning. Plus, what is that, 12? I'm gonna do 12 over s. S times 5 over s squared. Is that right? Yep. Plus 12 over s. Nice. I think that was exactly what we came to before. But, you know, you can do about that. Alright. Now we have t squared. Okay, this one's fine. u2 of t. Alright. The Laplace of t squared times u2 of t. u2. Okay, so that's going to equal, we pull out the unit step, so it's going to be e to the negative 2s, and times the Laplace of t, and we're going to add 2, so t plus 2 squared. Okay, so if it's the Laplace of t plus 2 squared. Do I have, I feel like I can't just, I feel like I can't just say that's equal. That's not necessarily equal to the transform of just t, right? Oh wait, I can factor it out. I'm silly. Me when factoring exists. Really, linear algebra is just, or linear differential equation, solving linear differential equations is really just doing algebra. Don't let anybody tell you otherwise. Yeah, there we go. That's a much more manageable transform, and it's also not equal to the thing that I said it was going to be equal. Was gonna say it was gonna be equal to. Okay, so we've got t squared, so that's 2 factorial over t cubed plus 4 times 1. I'm just gonna s squared plus 4 times 0 factorial over s. There we go. Now we're cooking with gas. We got the stove on. I've turned the stove on, even. Yay! Okay, time for partial fractions. I think. I'm forecasting partial fractions. I see big chunky numbers, and I'm a little bit terrified. Just a skosh. But we got this. We got this. There's 4 problems in this one problem. Okay. So A is the inverse transform of s minus 5. Man, why do you have to make it a 5? So hard to make it look different than an s. S minus 2 squared. Okay, we like that. We're gonna have to transform that a little bit. I think we can pull out a little funny little thing. Oh yeah, okay. But this is interesting because this is a shift. I think we should split it up into 2. And then we'll shift one, we'll shift the other, because there's different shifts. Yeah? Yeah. We're gonna have Laplace inverse. And I guess I could just pull out the shift already. So this is gonna be an e to the negative, e to the negative or e to the positive? E to the negative 2s. 2t. Because we're going back to t. And then we've taken out an s minus 2, and that's gonna go to s. So that's gonna be s minus 3. We've sucked up a negative 2 from the 5. This will be s squared plus 25, so we're going to cosine there. And then this one will be e the negative 6t. And the 1 isn't going to do Laplace. And this one will be 1 over s squared plus 2. Okay, so this one is quite easy. This one will be times 2 over 2. So it'll be like 1/2 whatever. You know. This one is a little more complicated. Okay, so we need the s. Yes, there. Would it have been smarter to do s minus 2 and left that one unshifted? No. No, yeah, no. I think it's smarter to pull it out. Okay. What do we have? We have e to the negative 2t. This is gonna be a sine and a cosine. Everybody's favorite. So s over. Do this. You know what? We all know that's cosine. That's a funny little cosine of 5t. So we're gonna go cosine of 5t. Now, it's shifted after, so we don't have to worry about that because that shift is taken care of. And then minus Laplace inverse. I'm gonna pull the 3 out. That 3 is not gonna help us. That 3 is high and dry over there. So 1 over s squared plus 25. Then we're gonna have to multiply this by 5 over 5. And then for this dude, we're almost done. This is gonna be e to the 6 over 2. And then this is gonna be sine of 2t? Yeah, maybe? Maybe? I'm not sure. I think so. Can you stare at it real quick? No, square root of 2. Oh, sneaky, 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 sneaky. That's, yeah. Square root of 2 is not 2. Not every number is 1. Rookie error. Truly. Okay, cosine 5. I just woke up and every number is 1. Be a fun world. Okay, minus 3. 3 over 5. Sine 5t? Isn't this just a great differential equation, you know? Like, you solve this and you're like, okay, what the hell do I do with this now? That's not my job. My job's just to solve it. There you go. Did I get to fluids too? I don't think they're differential. I say that, and then it's gonna be like, guys, there's so many differential equations in fluids too. Alright. Now we're cooking. Okay. B. I don't think I can fit all 4 of these on one page. I don't think I have enough space. I would feel really bad for the grader. A nice big line. Okay. Uh-oh, there might be some partial fraction decomposition in our future. 2s plus 3 over s times s squared minus 2s plus 4. Okay, what's the first? What shall we think about? Okay, what is this what is this factor to? 2s squared minus 2s plus 4. Nothing. Right? No? Wait, I'm lying. No, it's nothing, right? What is 2? 2, it's 1. That was me not, 2 is not 1. I'm trying to think, what is the square completion for -2 in the middle? It's gonna be 1. But I didn't say that. I said, what is 2? It's 1. Okay. If I do the square completion, I think that makes everyone hate me forever is the thing. Because we're gonna have like that s out on the end, and partial fractions are not gonna be a friend. Oh, we could just decompose this. Let's do that. Let's just do the long decomposition. We're gonna have... Okay, so it's gonna be... If we had a over s, and we had bs plus c, then we're gonna have a s squared minus 2as plus 4a, and then plus bs squared plus cs equals 2s plus 3. So I just said like a over s plus es plus 3, or plus c over s squared, because when we do this, we have to do that. Yeah? Yeah. I think that's chill. Partial fractions, my beloved, might be hated. So then we have a plus b equals 0, minus 2a plus b equals 2. Okay, we can get what a is, like, right away. And then... Yeah, this was definitely the move. And then... Cause then we'll be able to split it into some sort of t thing and some sort of cosine and sine thing, I think. I mean, because we can't factor this nicely, so... And then, okay, 4a plus c equals 3. There's an a. If we do this minus this, then 3a equals 2. Negative 2. A equals negative 2/3. B equals 2/3. C equals 4a plus c equals 3. So 4, okay, negative 3 plus 8 thirds. 9 plus 8 thirds is 17 thirds. Don't know about that one. Not too happy about that one, actually. Kind of sucks. Kind of sucks a lot. Is that really what that is? I mean, I could put it into a matrix and we can see if I... Let's do that, just to double check. I just wanted to practice doing it by hand a little bit, because I have an exam next Friday. I also have a fluids exam next Friday. I'm so nervous for my fluids exam. I want to do well. I did okay on the last one, but I didn't do that well, like, in terms of the real world. I did fine in terms of the curve, but you never want to be like, oh, I did fine in terms of the curve, so I'm fine. It was, like, kind of scuffed. It was almost a B. I mean, no. I know what his exams are like now, but I only have the midterm and the final left, and he doesn't, I mean, he gives a lot of quizzes, but... Oh man, I have to ask my friend for her battery charger. Okay, I just did -1. I need matrix. There we go. What is this? This is a 3x4? Yeah, I guess. Oh, I didn't mean to do that. Okay, edit. 1 1 0 0. Yeah, that's one. Negative 2 1 0 2 4 0 3. All you folks at home can play along too. You want to put in the matrix. That's the determinant. That's not what I need. Don't know why I did that. There we go. Negative 0.67, wait, 2 thirds. Yeah, 17 thirds. No, okay, I did that one wrong. Oh, A's negative. Wait, yeah, wait, what? What am I, what? What? If A's negative, 4A plus C. Going crazy? Am I going crazy bananas? 4A, negative... Hello? Did I do a goof? No, all my numbers should be positive if they're positive. What? Maybe I put my matrix in wrong. That's also entirely possible. Oh, I did 3C. Lol. Yeah, there we go. 1C. Give me that RF again, and it should be right. 5.6. Yes. Yes, it is right. A might be wrong. No, it's right. Hey, I still got it. Still got my linear. My 7th grade math class, adding 2 unknowns, Kramer's rule. I never liked Kramer's rule. I'm sorry, I'm a Kramer's rule hater. If you're gonna set up a 2x2 to solve a system, just row reduce it. I don't think you need to do Kramer's determinant rule. That's some guy from Seinfeld. Why would I trust him with my determinants? I'm gonna leave the constants as just constants for now, because I think that would be nicer. And I can just put them at the end. It doesn't actually matter at all, which is great. So A over S plus B over, whoops, B over S squared minus 2S plus 4. And for that one, I'm gonna do S squared plus 1 plus 3. That's gonna equal, oh, and then we have a shift, and then we pull out the shift, and then everything's beautiful and lovely. Okay, so this equals Laplace inverse transform of, I mean, I guess I don't even really have to do that. We're gonna do e to the, what is it? Just e to the t? Yeah, a e to the t plus Laplace inverse of, I'm gonna bring up b. I love how you can just play with numbers like they're fun little guys. So we have s minus 1 1 squared plus 3. And so we pull out a e to the t, that we don't pull that out. We pull out an e to the, okay, now is it a negative or positive? We're in an inverse. We've shifted this to be -1. Normally when we shift it, it goes to be -1, so it's going to be e to the t. And then we have Laplace inverse of 1 over s squared plus 3. And we multiply that by the square root of 3 over square root of 3. Don't know why that was chosen. Could have made that a little nicer. Plus b, e to the t. And then we have, this is r. Wait a second, sorry, I just got a flashback. This should be sine of like, one of these in here should be sine of, oh, I did put sine of root 2. Okay, good. I was just saying, it should be sine of root 2, not sine of 2. This is sine of root 3t. Yeah. And then, I'll put the constants in later. I don't know. I don't think there's anything I can do about them. Like, they're not gonna magically get better. I don't think they're wrong. Oh, whoa. My chair. Okay. This is a good boot camp. This is a good Laplace transform boot camp. There's a lot of, like, very similar transforms is the issue. Like, I got like, t to the power whatever. I got like e to the t. I got like sine, cosine, like all these kind of different sounding ones, but like these shifting ones are so similar, and like the negative and positive thing, it doesn't really matter because all that would be different is like I would have a negative here or a positive there. But it's like they're so similar, it's really hard to remember them. Let's see. Okay, so Laplace inverse of, hope all of you are winning at home. Or maybe if you're doing it, you're probably getting different answers because I'm getting them all wrong. I'm kidding. Okay, so we have an e to the -3s in our final function, which means nothing. If we have an e in our initial function, it means we're shifting it in our transform. If we have an e in our transform, I lied, it means we have a unit step function. Yeah. I think so. Ugh. Oh. Okay, this one I probably did wrong. I don't know, maybe I didn't do wrong. But I want to say it kind of seems like I did it wrong because these next two, the final fourth one is like completely square. So he probably wouldn't have us complete the square twice. He probably wants us to try different things. I'm just gonna straight up go ahead and factor this. This is, ooh, s plus 3 squared. The partial fraction decomposition for this, kind of nasty, because we have to do like an extra repeated root or something. Low-key, I could just factor it so that it's, wait, no, I couldn't do that. I lied. Don't listen to me ever. I was like, what if I just factor it to be one big thing? No. Yeah, no. Can't do that. I don't remember exactly how to do that, though. Okay, well, I guess I can pull our unit step function out. So, if we have an e to the -3s, we're going to have a u of 3, t, times the Laplace inverse, and we're going to change all our... We change all our t's, so not our s's. Our t's are going to end up as t plus 3. I think. For chance. Yeah. Now we just have to decompose this. I'd really rather not do. Well, it's fine. It's really not that bad. I'm trying to remember for this decomposition. I think we have to, wait. Track, decomp. with repeated root. I think we have to like do something a little special. Thank you, Khan Academy. Partial fraction, expansion, repeated factors, fractors, fractors. Okay, sorry. I just want to see this thing.
Times is all for everything else. So it's 24.
What is he doing? Sorry. Ax squared, b, what the freak? Oh, I see. Oh, we have to treat it as a b. Wait, what do I... Ax. Okay, so they have. Theirs is x minus 1, x minus 2 squared. So the x minus 2 squared, the x minus 1 is not. They do a x minus 2 squared plus b x minus 1 x minus 2 plus c x minus 1. Okay. Sure. Oh wait. Yeah, so we have to do the x minus 2 squared as another root. But I thought there was a way you could do it where it was like you just have it as like a. I don't know. There was kind of a different way to do this, but maybe I'm lying. We'll do it this way. So we have s minus 2 over s plus 3 squared equals a over s plus 3 plus b over s plus 3 squared. Yeah. Yeah. Okay, wait, yeah, it'll be a s plus 3 for a, and then b. Wait, isn't that just a s plus 3a? Whoops. Plus b over s plus 3. Oh no, we multiply by. Wait, won't that just be plus b? Well, I guess if we were trying to decompose it and we didn't do the squared, what would happen? It would just be a plus b, which is not right. Okay, yeah. So one of them, we just have to say like, got it. But is there supposed to be a c or not? Like, I'm missing something. I feel like it's a little goofy. Let me check. Let me see. Purple math. I don't know why math is purple, but it's there. Okay, a x squared plus 1. So you just do it again, I see. Oh, hi Scribble, how's it going? Factoring. Just doing some factoring on the side, you know. Just having a little fun with it. I'm good. That's good. Okay, I think this is right. I should move C to another page, though, because I don't have enough space to... I got a twinkle in my eye. I was like, ooh, I could do it on this page. No, I'm gonna do it on a different page. Do it on this one. Well, at least better than before. That's good. I'm really glad to hear it. It's always good to at least be better, you know? If we can't be good, we can at least be better. And that, I think, is a great place to be. We're getting somewhere, you know? Equals s minus 2. So we have, I guess, a equals 1. 3a plus b equals -2, so b equals -5. Random online voice training tutorials and stuff. Oh, awesome! That's so cool. I hope they go well. It can be so annoying sometimes. I will not lie. But it's very, I don't know. My voice change was like the biggest, like, epicest swag moment. I don't know if anybody is watching like the VOD uploads, but like I sound like a dying chicken. The VOD uploads. But I like didn't upload this one Calc 4 VOD I had, and I was like, oh shit, I gotta upload this even though it's out of order. And I was like, oh my god, my voice used to sound like that. What the hell? That is crazy. Okay, so if we were gonna Laplace this up without the constants, it would be s plus 3 plus b s plus 3 squared. I'm sure you don't sound like a dying chicken, by the way. I'm sure you sound great. Everyone is at different places in their journey, and that is pretty good. 3t. I actually do. No. This one is a shift of s. No, yes, it's a shift of s. So e to the -3t times t. I think. I'm just gonna not put in any coefficients. My goal, by the way, if anybody's seen the schedule, is like, I need to get linear done. Like, I need to get good at Laplace and everything. Like, well, I'm like mostly there. I just need to like do more of it this weekend, and then it's fluids lockdown from there on out. Just 24/7 fluid streams. I'm kidding, not 24/7. That would be insane. I don't think I could do fluids for more than a couple hours. Okay, this is clearly a completing the square one. When you see a 13, it's like, oh, okay. Now 6s. Okay, it's 9. I don't know why I got so excited about 6x. I was like, 36? That's so exciting. It's not 36. Oh shoot, I didn't do my t is t. I dropped my t to t plus 3. Wait. Oh, yeah. Okay. Me when I dropped the t plus 3. Teehee. Only way to get better is to practice? Exactly, for anything ever. I drew over my star. I'm gonna have to move my star. There we go. Okay, so we did that, and we're gonna properly carry this through. S minus 2 over s squared plus 6x s plus 9 plus 4, which is nice. I like that. I like seeing a 2 there, and I like seeing not 2. It's gonna make our lives so lovely. T plus 3. Same with my art. Oh yeah, it took me like 8 years to get to where I am now with art, so it's slow, but you know, it's try to enjoy the journey too. Try to enjoy the process of, if you can learn to enjoy the process of making stuff instead of just the result of stuff, you're gonna be so much happier with your art, I will say. Because then you're just like, la 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 la, I love art. Ooh, wait, I need the plus 3, so never mind, it's not gonna be nice. If we want a plus 3, let's see, if we snatch that from the 2, we're gonna have a minus 5. Plus minus 5. Don't question it. These sine and cosine ones are so sweetness though, they're so cute. They're like, I don't know, anything when we have like T's, I feel like it's so hard. When will I play Balatro? Over the summer. I'm in a game over the summer. I want to play, there's some actually games I want to play. I've been doing it for a year and I don't like it. Then again, I look at my first art and I can't even look at it. Okay, a year is so short in terms of art. A year is so short. Like, I know it feels long, but like, it's so short. Someone got a 10 to the 97th run? What does that even mean? That's crazy. Okay, wait a second. So this S plus 3 is shifted. That's gonna be an E to the E to the 3t? No, minus 3t. Man, I gotta check those signs. Oh, an E to the a 10 to the 97th score. Okay. I see. That makes more sense in my brain. And we have t plus 3 instead of t. And then minus, okay, this 5 is gonna be times 2 over 2. Okay, it's kind of hard to put this in here. Okay. This one is also shifted, e to the negative 3t. I guess I could have just pulled that out, huh? But that shift is from the s plus 3, yeah. And then sine, okay, 5 over 2. That sine 2 t plus 3. Oh, you know, classic little answer. Oh, little dude, I love this guy. My best friend. Sick. Okay, so that's the second problem out of 8. Man, this is gonna be a long homework, okay. This is gonna be a long problem set. We're in for the long haul, it's okay. What was this one? That one was actually 1. And this was 2-1. What is up with some Twitch emotes like... like, shush. Wait. Send that one big so it, like, displays really big. Oh, wait, I don't know if my chat does that. I don't think it does it. I lied. Don't do it. In Clem's and Rev's chats, they have a different chat box than I do. Maybe I'll switch to whatever they use. But, they make it makes the emotes really big when you send only an emote, so you can see it huge. Ooh, solve the initial value problem. Ooh. Y prime minus y equals, I'm just gonna put this as a piecewise function right now. Okay, so we have, I guess, t, and then at 1, so we have unit of 1, t, times t. We turn off t. Paimon is a default Twitch emote. I know, Paimon's so cute though. And at 1, we turn on e to the negative t minus 1. There we go. This function looks like this. Like that. Something like that. And this is 1. And this is 0. Just... that looks like. Okay. Alright, are we ready to Laplace it up? I'm gonna speedrun this. Oh, our initial conditions. Y of 0 equals 2. Oh, it's only a it's a first order differential equation. Okay. That means we have s times the Laplace transform of y minus 2 minus the Laplace transform of y. So I just took the Laplace of that side and I just expanded it out quickly. Equals the Laplace transform of t minus the Laplace transform of u1 of t times t, which I guess I could also do out really quickly. Let me pull out the Laplace actually. So it's gonna be e to the negative t times the Laplace t plus e to the negative t times the Laplace of e to the negative t minus 1. Okay, actually, before I do that, this is going to turn into t. This one is going to turn into t minus 1. My curly braces, I'm doing so many of them, they're getting worse. There we go. There we go. Okay. You like that? Yeah. Okay, I'm gonna collect the coefficients, so we're gonna get an s minus 1. The y equals the inverse Laplace of... My linear class ended, so I'm glad I get to see more math on your streams. Let's go! More math! Poggers! One of the cool things we were talking about is... And we'll probably do it... I think the next... No. There's a problem down here, so one of the cool things for... Or the reason why, like... we use Laplace transforms to solve engineering differential equations is and also like so electrical and mechanical. So like one of the systems that like we model with differential equations is a spring mass damper system. So you have like a mass on a spring, and then it's like connected to a damper that's drawn like that, so it kind of stops the oscillation, and it oscillates up and down. And so, when you do linear 1 here, linear algebra, like, you kind of model this by, like, an e to the t, right? If it, like, is overdamped, or if it's, like, perfectly oscillating, or if it's, like, underdamped, right? Like, no, wait. Yeah, underdamped, it would just, no. Overdamped, it goes like this. Underdamped, it goes like this, yeah. But one of the things that we were interested about is, like, if we have a system that's doing something, maybe it's, like, overdamped or, like slightly overdamped or something, but at some point if we just hit it with a baseball bat, or like if we have a voltage spike in our voltage, or let's say like a bird flies into our plane wing that we're building, and it just goes wham, and it goes like up really high, and then like it does something weird, you can use Laplace transforms to model that behavior, because it would be really hard to do this with linear algebra differential equation solutions, because we want to use because Laplace is a linear operation, we can use the principles of like superposition and being able to add solutions on top of each other, because it's a linear differential equation class as well, and we can model that like really funky behavior after a certain time. And so doing unit step functions and stuff is really cool. I don't know how much you guys did in your... I'm kind of jealous, because it sounds like you got to do way more cool stuff than we did, because we were the first people who took that class. And, we were kind of the guinea pigs. But, yeah, it's pretty cool. That's called and the function that you use to model that is like... It's a function that you have, like, over on this side, that's, like, your forcing function. So, like, let's say you would, like, take a spring, and it would just be like this, and then at the start, you would, like, pull it down some amount, right? So it's like the string is slightly stretched, and then you let it oscillate for a little bit, and then at some time, you just, like, impart an impulse onto it, and it goes, like, up or down or whatever. And we model that with this function called the delta Dirac spike. And it looks like this. Oh, okay. It looks like this, kind of. It's like this very small spike that exists, and it goes up to like infinity. But it's like the right amount of infinity is the way that my professor described it, so that the area under here equals 1. Oh, OMG, Dirac delta function. We use that in quantum mechanics too. Oh, that's so cool. Yeah. So because this area equals 1, I don't know if you guys do it in Physics C, AP, but like the area under a force time graph is impulse, right? So change in momentum, which is obviously really useful if we care about like finding the energy or finding, the position of this or whatever. And so we can use this to impart impulses on stuff, and it's pretty sick. It's pretty cool. And you can do that so easily. You can do it so easily with Laplace transforms. Laplace transforms are actually so cracked. But I mean, like, I understand why we do it the other way, too. Where were we? Laplace inverse. Okay. All the stuff that's on this side. So Laplace inverse of t is going to be 1 over s squared. I'm going to divide it all by the giant thing. Minus e to the minus t. I lied. This should be e to the minus s. Okay, let's get my variables right here. Me just mixing t's and s's, not great. So t minus 1 is going to be 1 over s squared, or sorry, 1 over s squared minus 1 over s, and then plus e to the negative s of 1 over s plus 1. Yeah. So funny. We were learning about this thing called the convolution, and we're probably not going to get to it because it's like 6 problems in. But it's like, it's this. It uses an asterisk, so it's a thing you do to functions, and it basically means like you take the integral from 0 to t of f of t minus tau. So you have this sort of like dummy in between variable that you're switching stuff out, and you do this integral, and it sort of goes along like if you have one function here and one function here, it goes like and multiplies like these two values instead of multiplying like two values here and here. And so it's kind of like a product, but it's like weird. And he was telling us this story. He was like, okay, on my last exam, people thought for some reason I was using some fun new multiplication sign. He was like, but I gave them a multiplication like in the other problem, so they're kind of silly because it's clearly not a multiplication sign, and also why would I give them 2 multiplication problems? I was like, yeah, that's probably gonna happen to at least one person in our class. I'm projecting that to happen. Oh, and then we have to divide by, this is gonna be our s. Oh, also, I lied. We have to do Laplace inverse of 2. So minus 2. That in there. And then divide all this. Divide all this by s minus 1. Okay. So where do we go from there? Where do we go from here? Let's see. We have y equals the inverse Laplace of 1 over s minus 1, s squared, minus e to the negative s of 1 over s squared, s minus 1. Okay, we can factor that out. I should probably factor that out. Plus e to the negative s of s times s plus 1. I looked at the wrong thing. S minus 1. Plus e to the negative s. I guess I could factor out e to the negative s at a lot of these, but s squared minus 1 minus 2 over... Okay, we like the 2 over s minus 1. That makes my life easy. Let's consolidate. So that one's going to be a cosine, and that's going to be a unit step function on the cosine. I'm looking at the third term, or fourth term. And the last one's going to be an e, so that one we like. The other ones, they're going to be shifts. Not really going to matter that much because it's going to shift it, but it's going to shift the other one too. So like that s minus 1 will turn into an s, but the s will turn into an s minus 1, I think. And then the 2 really annoying, well, the 3 really annoying ones, I guess, are the... But can I actually... Wait a second, I don't know if I can... Oh no. Because it's gonna be e to the minus s. Wait, what is he asking for? Solve the initial value problem using the Laplace transform. Okay. I wanted to make sure he wasn't just asking like for some in-between step. Okay. So if we factor this, we get 1 minus e to the s over s minus 1 s squared. I don't like that. I don't like that at all, actually. I think that's bad. I think that's nasty. I think that's nasty. But case in point, I also think this is nasty, because this one is going to be annoying to decompose. Let's clean it up a little bit. We can clean it up somewhat. So we'll split these into separate Laplaces and do out the easy ones. Okay, so the e to the minus s can pop out as, let's just check. So if we have an e to the minus s inside our inverse Laplace, That means that that's what? Wait, what? What the heck? What the heck? Wait a second. What was I proving here? I just wrote e to the minus as times f of s, big F of s, equals e to the minus as times Laplace of little ft. Wait, okay, no, it's unit step function, yeah, so... Okay, that's a bad result. Why did I write it like that? Man, why is that that's the one I need, and I wrote it, like, really poorly. Okay. On past me. Okay, let me try and... Let me try and look. I'm looking in my big brain. Here we go. F of t. If f of t is... No, sorry. If f of s is multiplied by e to the negative as is a second shift. Okay, what do I do with that? Okay. Do you... Oh, I just shifted by... Okay, it is just the... It's the... Okay. It's like this. I'm gonna write it like this. This is the way that he has written it. It's slightly different than what I was doing before, but we're not gonna do it all in one step, so it's gonna be Laplace inverse. I lied. It's gonna be u of 1. So e to the negative as. U of 1t. Times the Laplace inverse of 1 over s squared s minus 1. Well, that's nice because those two will actually be the same thing, so we only have to do that once. And then we say t goes to t minus 1. Is that true? Let's see. That was multiplied by what? E to the negative s. This one is multiplied by e to the negative s. So we're going to the minus 1. Okay. Same dealio for why did I draw this? What was the point of that line? When did I draw that line? Okay, I'm gonna chalk that up to I was trying to maybe move the board. Okay. So we have another u1 of t. Laplace inverse of 1 over s times s minus 1. Oh god, we're running out of room. I tried. And then plus... okay, e to the negative s, so this is a u1 of t times... If it's s squared minus 1... Wait, is that like I? Uh-oh, is that I? Might be I. Maybe I have to decompose that. I don't know if I can have an I in there. I'm gonna leave that one. u1 of t times the Laplace of Laplace inverse. Whoopsies. 1 over s squared minus 1. I may need to decompose. Minus 2 e to the negative e to the negative t. Yes. No, e to the t. God, the negatives and positives are so hard. Okay. I don't want to do all this partial fraction decomposition. Fuck this. I want to do a delta function or something. Frac. Decomp. Lol. Okay, I'm gonna do delta now. Man, I'm gonna have to print out so many pieces of paper for this. Okay, it's fine. Okay, find the Laplace of y. Okay, just find the Laplace of y. I feel like sometimes you don't even believe what you're saying or doing. You just be saying things, making things up. No, okay, I believe. I believe very hard. All these things are things that I should be saying. The question is I have like a million... I have like, there's so many signs in this that I'm like, I don't know, because it's either like, okay, you have e to the negative as, but sometimes you have e to the negative, like, negative s times a, so like your a isn't negative. It's really, it's quite tricky. You could probably decompose 1 over s squared minus 1, but I think that's the form of Laplace of hyperbolic sine. There's no way he wants us to do the Laplace of hyperbolic sine. We have to know, okay, the transforms we have to know are like e to the t to the n, as in like t squared, t whatever. We have to know cosine, sine, 1, the delta function, the unit step function, and like that's it. Well, it just comes back to like 1/2 e, let's see, 1 over 2 e the t, making things up so hard. wait, how does it, wait, what? It comes out to that? Wait, because it'll be 1 over s plus 1, or a over s plus 1, plus b over s minus 1, right? Manifesting stream? I love this stream. Oh, 1/2 e to the t minus, yeah, okay, that's real as fuck. Okay, that's definitely, you're better than I am at these problems. I can't believe you like know how to do this and you like didn't even, like, bro, I've been doing this for like 3 weeks and I'm not good at it. Plus 2y prime plus 7y equals the delta function, let's go, of t minus 4. I don't remember if I told this story, it was so funny though. We were learning about the delta function and this one guy in my class was suggesting this problem because we like had extra time, and the professor was like, somebody give me a problem, and he started writing on the board. He was like, oh, y prime plus, and he was like, oh, equals delta t minus pi over 2, and everyone went, oh, and then he went, oh wait, no, t minus 2, and everyone went, yeah, and my professor was just losing it. He was like, guys, you know that doesn't make the problem any different at all. It's literally just e to like the negative 4s if it's that. He's like, he was losing his shit. He's like, look at this mad lad, he's doing pi over 2. Come at me, bro. I was like, yeah, dude, that's so funny. Oh shit, there's more. Okay, that's shifted. Oh, it's hella shifted. There we go. I think I said that's hella shifted when just this exists, and like, yeah, these two things are... Oh my gosh, hi Cosmo, how's it going? We're getting up to funny business with transforms. Okay. I'm just looking for L of Y. I'm not looking for... He's going so well. No. I'm just too... I have to edit all of my VODs. And I've been editing them and re-uploading them, and I hate the demon mic. This summer, I have to figure it out. We are exercising this thing once and for all. It's gonna happen. I don't know why I did that. 7, why? It was excited to see you, Cosmo, the demon mic. Oh god, okay, so... okay, the delta function, what is its... What you said this summer made you sad you were beautiful. This summer, Damie exercises the demon mic. It's literally just e to the negative. Sorry. E to the negative 4s. Smiles. The demon mic was more excited to see me, I think. Yeah. You were not excited to see him. Biggest hater. Okay, this is a shifted little funny thing. So it's sine, which is 1 over... Not 1, it's gonna be I over s squared. But we're shifting it by... Nope, we're not shifting it. Sorry, I lied. S... If there was an e to the t in there, we'd be shifting it. S squared plus pi squared, ew, times e... Sorry. Didn't say ew. E to the negative 6t s. And I say, leave this place, foul thing. You and Mike's love me so bad, and for what? Well, they're around. They're there for you. You know what I mean? If nobody got me, you know who got me? Demon Mike got me. He's always here. Whether I wanted to be or not. He's just there forever. I feel like if I internalize the difference between the letter S and the letter T, then I will have a lot easier time doing these problems. It literally just wants me to find Laplace of y. It doesn't ask me to solve for the other stuff. But I feel like that's a trick question because it's like, I don't know. It feels like sneaky. But maybe it's not. Maybe it's to be like, haha, everybody's wrong. Everybody's wrong because they actually did more math than they had to because they didn't read the question, which is an alarming amount of questions in college. I'm not gonna lie. There's like a 25%, 33% chance that like a question is just like, haha, you didn't read the question and now you got the question wrong. And you're so dumb because you didn't read anything, because you don't have any time to read anything, because I hate you forever. And I was like, whoa, okay, dude, maybe chill out. Maybe we just, like, love each other, and you give us questions that, like, are not, like, cryptic, that I have to, like, decode. But, you know. I feel so silly sometimes when I come into your stream and doing super intensive smart math problems and I come in and I say things like microphones want me so bad and you're okay with that entirely. No, that's beautiful. We need the banter is the thing. Math does not exist without banter. Like, my professor, he just like took a call in the middle of class and he was like, oh, my son like thought his leg was broken or something. Because he's a young kid and like his leg, he had an injury or something. He was like, no, it's just a real estate agent asking me if they want me to sell my house that I'm living in right now. He's like, sorry guys, I can't finish the question. I have to go move to Ohio. I'm a mod and I come in and spit stupid shit. Don't worry, math banter is so real. Yeah, that's why. You gotta have the bants. I think that's it. I think that's just it. I think that's the answer. I wish Rev was here. I love it when Rev like tries to guess the answer to problems, because Rev would just be like, what's the answer to this? Oh yeah, 3. I would be like, hell yeah, Rev, it's totally 3. Sorry, that was me on the line. You were trying to get my professor to sell his house. This is the stupidest question ever because I can't put any more questions on this paper and I've used like 1 inch of paper. It's 468. It is 468. You're so smart. You got it. No way. Wait, what the? Did I use? Oh no. Okay, we're chilling. That's 4. We get to do a spring mass problem, everybody. Yippee, yippee. We love springs and masses. The only thing you ever do in your life ever. Sorry. That was a little bit of a hater moment there. I'm not a hater, I swear. I like a good spring mass system, but sometimes it just gets a little boring, if you know what I mean. Does Laplace let you solve second-order non-linear, non-constant coefficient differential equations? It does not let you solve non-linear differential equations. Or, I'm pretty sure it doesn't. I mean, you could probably take the transform of stuff that wasn't linear. I mean, you might not be able to do anything with it. Wait a second, I can tell you a better answer to that. Wait, there's something you have to... No, okay, so the only things you need to be able to take a Laplace are it needs to be integrable from 0 to infinity, because the Laplace of a function is just f of t times e to the negative st dt. That's all you need to make a Laplace version of the function. So it needs to be integrable, and it can't have a bajillion discontinuities. That's all. If it's not linear, things start to get a lot harder. But second order, yeah, you can do second order with it. And non-constant coefficient. You're trying to solve, okay, let me see. Y double prime minus 4 over t y plus 6 over t squared, oops, sorry, y prime, equals 0. This, to me, okay, it's been a long time. But so there are some first, this will be discontinuous at 0. Is this, can I have a little context on this? Is this like a model that you've made, or is this like a textbook problem, or like, because if it's a model you made, we are in the Wild West. If it's a textbook problem, it's just an IVP. It's more like, what's the like, where's the origin? You know what I mean? From my teacher. Okay, it's probably solvable. So, I don't know. It's hard because when you're solving differential equations, there are a lot of different cases, right? But you kind of just have to know. I asked 2 other streamers and they worked it all out and failed. Well, here's what I'm going to tell you. It's been a year since I've done most of my math, and most of my math is just saying like, what's the integral over a control volume of rho dot dA vector, stuff like that. So I mostly do like multivariable applied and like other stuff. I don't do a lot of differential equations that are not essentially not spring mass, because a lot of the things that you do in physics are acceleration and velocity and position. So I have a very low chance of being able to do this. What I will say that maybe the other streamers would not tell you, they might, I don't know. But what I would say is there's a chance that this is like a very special form. Well, so Laplace can work with discontinuous stuff. With restrictions, no Laplace or power series. Oh, power series might be good. Laplace can be discontinuous, but it can't be infinitely discontinuous, is the thing. So like you can have like a piecewise function, right? Like, so if you had something like this, the example we did was like something like this usually. Like if you have a line and then it turns into another thing, because you can split this, because with the Laplace, right, you can split the integral up, like let's say this is 1. You can split it from 0 to 1, and then you can do 1 to infinity, and you're all chill. But you do have to split that up, which kind of sucks. But if you can represent this as a piecewise function, so if it's discontinuous after, no, it's more like if you have a bunch of discontinuities, like forever, like an infinite number of them, you just would have to infinitely make integrals, and we don't really have enough paper to do that. Also, we don't have enough time, because there's an infinite amount, and that would take you an infinite amount of time. But yeah, there are other ways that you can handle those kind of things. Thanks for the help. Yeah, of course. I would say maybe, like, because, I don't know, to me this kind of reminds me of like a Bernoulli equation, but Bernoulli is for first order. But those t squareds, it could be some substitution thing. Power series... Actually... Power series with Cauchy-Euler? Yeah. Have you tried, like, a Cauchy-Euler-like? Sorry, that's not gonna mean anything. Have you tried the, have you tried Frobenius theory? Me when I actually get to say something? T squared y double prime minus 4t plus 6y equals 0. And then you solve this by... I have no idea what that is. Oh, let's go. I can actually help you out here. No way, I can actually do something. Okay, so Frobenius theory is an extension of power series theory. I thought you said Cauchy-Euler. Yeah, pretty much. Okay, it's an extension of power series theory, essentially. It's like the general form. So instead of having a power series where we go from n greater than 0 of like x to the an, x to the n, we're gonna do power series of, I'll call it b sub n, of x to the n plus r, where this r value is something that stays the same, and we can create things like power series of x to the 1/2, or power series of x to the 4/5. And then you could do, like, you know, obviously like x to like the 9/4 would be the next one. To solve this, you would set up, basically you would say your y is going to be, equal to n greater than or equal to 0 of a n x to the n plus r, and then your derivatives are going to be, the one thing you have to be careful about is if you've done power series, this number is going to be able to be increased because that constant turns out to be 1, but in these we can't do that because it's n plus r. We say n plus r minus 1 times n plus r. We're just taking derivatives of this power series. And then n is 0, a n, x to the n plus r minus 2, n plus r minus 1 times n plus r. And then you just plug that into your differential equation. You're gonna have to do like your orphaning terms and stuff. I don't know if you've done power series. It says we didn't do power series or Laplace in my class. Well, I can show you real quick. Unless you don't want to solve it with power series, that's pretty cool. Yeah, so Frobenius theory, like you have a bunch of different cases. Essentially, we're gonna get some values of r for these r roots by the coefficients in front of these. So it's gonna be like, we're gonna say, and if you'll notice when we multiply by t squared, in this case my t, I've like turned it sort of into an x or something, right? I'm gonna sub in t for x. So when we multiply this, we're gonna get n greater than 0 of a sub n x to the n plus r. It's gonna go away, right? Because we're gonna add that 2 that's out in front here to this minus 2, and that's gonna be plus 0. We still have these here. Plus n greater than or equal to 0, a sub n, x to the n plus r again, because we've multiplied by that, and that's by design. Like, we chose, when you learn Frobenius theory, This is the penance you pay for for learning how to do math. You get your ears exploded by the Pharaoh's curse. I'm so sorry. I have issues. That's I don't know how to describe that other than electromagnetic interference that I don't know where it comes from. Cursive raw, yes, essentially. Anyway, so back to differential equations. When we're gonna have to, actually wait, this is like a really nice version of this. When we combine these, we're going to, wait a second, we don't get any orphan terms. Excuse me. Wait, is this not just a Cauchy-Euler equation? Is this not just literally straight up Cauchy-Euler? Am I like pooping my pants right now? Isn't this just like r squared minus 4r plus 6 equals 0, and then you get r plus or minus. It probably is Cauchy-Euler. Yeah, r equals. So what do we have? We have r 6. Oh, is it gonna be? It's probably gonna be 4 plus or minus the square root of 16 minus 24. Oh, it's gonna be i's. Oh yeah, we're chilling. Yeah, 2 plus. Yeah. Plus or minus the square root of what is that? Or 8. Negative 8. So we're at like 2 root 2i. No, root 2i. Root 2i. No, maybe. 4, 2, yeah. Okay, so then, oh, this is so easy then. Oh, you're chilling. Oh, you don't even have to do all this. I mean, this still gives you the same. That's how you spell Cauchy-Euler. Yeah, Cauchy-Euler. This dude is so crazy. He went blind, but he made so many math theorems. He went blind, and he got somebody else to write for him so that he could still keep making math theorems. This is literally just going to be y equals... And so this is a special form that you have to know. I think it's y equals sine and C1. So your C1 is going to be a little different, right? Like your C1s. Oh, so you chose a different... Oh, wait, no, yeah, Oh, it's a little different when you have, what's it called? Imaginary roots. I want to check for you that. Wow, I'm really glad I helped you. And you got a bonus of Frobenius theory other than just I roots. I did this so much. It's actually a great review for me. I did this and then I forgot about it. What happens? Sorry. In particular, I tried t squared, then multiplied t. Oh yeah, no, you don't want that. It's fancy stuff. Let me. I got you. The thing about Cauchy-Euler is like if you have like an x squared, like you can have a Cauchy-Euler like, and for complex normally it's that's what it is. Wait, why did you try to do the t then? It's just you just multiply by that. That's Oh, when you plugged it back in, it didn't work or something? It should work. Someone told me to try t cubed. Why did they tell you to try t cubed? Oh, okay. Here's one thing I can also say. There are certain ways to like kind of, I mean, Frobenius theory, like this kind of stuff, this kind of power series stuff is gonna like help you kind of attack more problems that are pretty much like anything you can do. Like, because Laplace is an extension of this theory. We're essentially just saying instead of having set intervals that we can plug in numbers, what if we could just plug in every single number for Laplace and have it be a continuous function? That's where we get the integral for Laplace from. Cubed is what they call it when you go at HRT 3 times. That's what they tell me to do when my levels are sub-therapeutic. So yeah, it'd just be c1 e to the negative... No, you're so right. It's c1 e to the negative 2t times cosine of square root of t, and then plus c2 e to the negative 2t of sine square root t. Minus, I think, maybe. I don't know. c1 doesn't matter. Maybe not negative, sorry. That's my Laplace spilling over into this. I don't know if that helped at all. Maybe it did. It is negative. I think it is, but because there's a constant, you could just slurp it up into the constant. Oh, in the e power? Oh, you're probably right. Oh wait, yeah, because it's gotta converge. Lol. Got something in my brain in there. Remember something. It seems like you know like what it is though. I feel like you got it. If you were interested in doing this, you would combine these all into one big series. You would say n greater than or equal to 0, and you'd factor this out. You would say an, I mean, you can factor out the an too. You would get n plus r minus 1, n plus r. This is if you wanted to like actually figure out the series of it. Scared me with the t's in there. I didn't know what to do. Yeah, sometimes it's usually like we use x, or if you like see my problems when I do them, we use x, but it's not scary. It's just a little Cauchy-Euler. There's another old man guy. And plus 6. You get a n x to the n plus r. And then you set each one of these. You find a recursion relationship and blah, 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 blah. Thank you for all the help. Oh, of course, of course. I'm just really glad it was actually something I could solve, I'm not gonna lie. Usually when people come in here asking something, I cannot do it, and then I'm like, oh shit, I can give you like a hint probably that might help. But then I'm like, I don't know. If you have more linear diff-EQ stuff, then because this is a linear differential equation. When it starts to get non-linear is if you like squared y prime or something like that. Would be, I don't know how to solve that. I thought it wasn't linear since t is squared. No, this is a linear. Cauchy-Euler is totes linear. It's just that, yeah. So like if you had the other like kind of application is if you had like the Frobenius theory type beat is if you have like a 4, if you had like x minus 1 y prime plus 6x y or something. So like your x minus 1 isn't really, it's not really Cauchy-Euler because it's only nonlinear when derivatives are squared. Yeah, if you had like if you had the square root of y, or you had like the cosine of y double prime or something like that, then yeah, that is when you are absolutely borked and you can't do linear. And you have to just cry and hope someone else has already solved the problem, because that stuff is hard. The other thing is like there are certain functions too that are specific. If you haven't done power series, you're almost definitely not going to talk about it. But there's something called like a Bessel function, which is another sort of linear differential equation where it's like y. It's what is it? I think it's x squared y double prime plus x y plus x squared plus p y, or y like that equals 0. And this is something that gets used in engineering a lot for modeling vibrations on a circular surface, so like on a drum or something. And there are some other like special cases, but these are more like I don't know if you probably also haven't heard about them, but there's this thing called the Legendre polynomial about terminating series. I don't know. That's all series stuff though. That's, yeah. Wait, so are you in like an intro sort of differential equations? Because that seems like it sounds a little bit more like, oh, you're doing sort of this auxiliary polynomial type stuff. Yeah, I'm in intro to, yeah, okay. Yeah, don't worry about this then. Don't worry about this. I think the reason, like, if I can just step back and think like why they would give you something like this is because, right, when you're solving your differential equations in sort of your intro, you're trying to find this like auxiliary polynomial where you can get like r values and then those turn into e's, right? But this is sort of like that, but it, like, the real theory behind it is a little bit more complex than just doing this. Like, if you want to do it in any other situation, it's not going to be like that. But was thinking it was phase planes and Lyapunov stability. Okay, I don't think I did that. Phase planes? I did phase spaces, which were like these things, the solution spaces. I like these a lot. These are cool. I need to like get back into phase spaces for eigenvalues. These are so cool. They're just like you can have like an unstable spiral. Yeah, that stuff. It's so sick. This is really cool. Stability of critical points. Oh yeah, okay. I did do that then. Coolest looking graphs I've done? Oh yeah. I feel like the coolest graphs I've done actually started to be in like my fluid dynamics and stuff, because getting to model graphs like of these are like the prettiest looking graphs. Like, I don't know, I just love the way that they're like they were so fun to draw. They were so cool. Oh, Mike is slightly borked. Probably. Let me unbork it. So this is scuff screen here. Not fully borked. Okay, good. It borks itself. We do a little borking. Alright, where FO is okay. Alright, well, I gotta get back to this mass spring problem, but if you have any questions, feel free to hit me up. Oh, I do have a Discord. I don't know, if you have any other questions, feel free to ask in there or just DM me. I have your mileage may vary with whatever time I'm active, but if you ever want to ask stuff. I do engineering math mostly, so like if you are a math major and you're like learning this stuff, then I probably won't be able. There are some math majors in there though, if you have questions, but I probably won't be able to help you personally if there's more math majory things, because like the extent of my knowledge will end at like Laplace transforms and I don't know, what else do? We do like inner product spaces. Want to do software engineering? Ooh, software engineering is cool. Like microchip stuff or software engineering like coding stuff? It's a lot of math to take for software engineering. But I guess if you do data structures or something. Coding, but I'm doing a minor in ECE. ECE. I don't know what that is. It's giving me... Oh, electrical computer engineering. Got it. That makes sense. Electrical is tricky. I have a lot of respect for electrical. At least with all the mechanical... I'm a mechanical engineer. All the mechanical engineering stuff, like, you can see it happening. It's like, oh, we're doing fluid dynamics. We're turning this big-ass wheel, and, like, you know, there's jet of water spraying here, and, like, it goes back, and we can see what happens. Even if, like... You know, the buckets look like funny butt shapes or whatever that like split the flow down the middle, and like you don't really know where it goes. It's still like I kind of know what happens. But electrical's like, man, there's electrons in there and they'll kill you if they touch you. Get out of there, bro. Okay, at sig equals 6 seconds, it's dealt a blow in the negative direction. Oh wait, we just have to add delta function. I feel like electrical has a lot of analogous parts to mechanical. Oh, for sure, absolutely. Yeah, like all of this stuff. This function, for example. This is like if you have a voltage, an AC voltage in your circuit, and then it spikes, and then it has to go back to the point where it gets to normal and is at a new steady state. And that's why like EEs have to take this class that I'm taking as well. But I mean, it's also like if a bird hits your airplane wing, or you know, if somebody takes dynamite and blows up your car, what happens to it? I didn't know. Let's model it. Or if like internal pressure combusts in your engine or something, right? Like, or what would cause it to do that? Or like, what would the shrapnel look like? Are we given initial conditions? Yes, we are. Y of 0 equals 4. Hey, at least the y prime equals 0. Hey, we love initial conditions of 0 here. So Laplace of y, and then we're gonna do plus. So I'm just turning the y prime into s squared y, and then we'll have minus s times 4. So that's our initial condition. And then plus 0. And then plus 4 times the Laplace of y. Ooh, that FO, oh, the FO is just constant. I've tried to follow you like 20 times and restarted my browser and it doesn't work. Oh my god, Twitch hates me. My mic demon is blowing me up. It's getting me. I had to do it on mobile. Oh, thank you for the follow. Cosine s over s squared plus 25. Oh god. I swear I remember how to do things. Okay, D. Wait, do I need the U of 6? I think I need the U of 6. Which means I need to multiply it by something as well. Okay, if my initial function going into the Laplace, it's gonna be a shifted Laplace? No. No? No. It's gonna be like E. Is it not like E to the... Because U of 6 is going to be e to the negative 6s. And D of t minus 6 is going to be e to the negative 6s? Wait, what happens when I have a unit step function and a delta function? Oh, something happens. Oh, that one we just did. If I had Tulip OST in my in progress on stream, would you care? Oh my god, no, get it, take it. You're not stealing my... I don't own Julep. You're so fine. I have to expand my playlist too. I don't have Mario Galaxy on here. All my Pikmin music is like so quiet. It's like if an ant was playing Pikmin. Like, you own Julep. I want to play Julep so bad. I would have to emulate it. I don't know if Nintendo would kill me dead. They would hate me forever. Why did I do so many steps in one step? Where's my Laplace? You're gonna smite me down? Oh wait, I have a perfect emote for this. I never get to use this emote. It's in my like. There we go. There we go. Damie Tulip is for the PS2. I know I don't have a PS2. I thought you said like Tulip is for the PS2 Damie, and I was like, who's the PS2 Damie? I'm me. I'm the PS1 million, baby. I'm a PlayStation they don't even make yet. Delta function. What am I doing? E to the negative. Yeah, it's e to the negative. Oh, you are the PS2. Where's my unit step function? I just need to multiply two things together, and I'm really failing at that. I love failing so hard. Oh wait, no, this is the one that I wrote. So shitty. I love this emote so much. I know, Clem's emotes are so... I need to redo my emotes. I love having Pinot as an emote, but I don't think anybody's gonna use Pinot is the issue. I need to like have some more normal emotes that people could actually use. Like, you know, maybe like a laughing emote or like a Mike Demon emote. I will use Pinot. There he is. There he is. That's my little guy. My little... No. I think it's e to the negative s and then e... I think it's that. Maybe. There he is. There he is. My boy. Okay, what was I doing? Okay, y equals the inverse Laplace. Let's see if I can do this in one singular step. FO s over s squared plus 25 times s times 4s. Nope, that's not what it is. S squared plus... Oh god, it's gonna be so annoying. Wait, we can decompose this into two sine and cosines. Wow, that's gonna be a bad function to do though. Kind of wish I could like. Well, I guess he posts the answers to the homework. I just never like looked at them. Oh, I'm a bad student, huh? Me being like, I really wish my professor, posted answers to homework. It's like, Damie, he doesn't even know. I add them. E to the negative 7s? That feels wrong. That feels evil. You're the most kind student in the class we call life. Oh, that's great. That's so beautiful. Wow. I never thought about it like that. It really makes you think. Wow. I'm gonna shed a singular tear. Wow. Plus 4s over. Oh, my brain. S squared plus 4. Okay. Did you get a calculator in DiffyQ? I'm not allowed one either. It doesn't really matter a lot. The only thing you could possibly want it for is like partial fraction decomposition, I feel like. I get a calculator in every single other one of my classes because nobody cares if you program, I think the way they see it is they're like, okay, if you take the time, like for example, my civil engineering class, it's pretty much like only just like, can you do these equations? Can you get the correct values to put in these equations, right? And it'll be like, if you get a stress matrix of like sigma xx, sigma xy, sigma yx, sigma yy, and then you multiply it with another matrix that's literally just sine of an angle, cosine of an angle, sine of an angle, negative sine of the angle, cosine of an angle. If you manage to write a calculator program on your calculator that did this, I feel like they're just like, you put in more work than most of the people who take this class, so they just let you do that. I've been scared to put in programs. Normally they don't specify if you can use it or not. I do a bunch of matrices in my circuits class. Yeah, I mean, I think like, my calculator has matrices, so the reason, at least for my school is pretty lax on caring about if people know what they're doing or not, is what I would say if I was trying to be nice. Oh, nothing with variables? Yeah, there's a lot of like, I remember when I did, because I had to take circuits. I haven't taken my second circuits yet. But like, we did a lot of, for node voltage analysis, that kind of stuff was all matrices. We had a calculator, we were allowed to use a calculator. But yeah, so my school's pretty lax on it, so they don't really care if people use calculators or whatever, because they know that people don't really, they're not going to like put programs on them, because either they don't know how or they don't care enough. But the reason why is for engineering certification exams, they don't let you use like a graphing calculator specifically. They'll let you use a scientific one, but not a graphing one. So, they try and have us like do that so that when we're taking if we want to get certified for whatever state, then we can be certified, but Okay, there's a nice Laplace hidden in here. And then there's the other ones. I should draw Laplace transform as a little creature. What would the Laplace look like? Oh, that would be so hard. In digital circuits, I couldn't use a calculator because they want us to convert binary, hex, oct, decimal by hand. That's such a waste of time. Just put eyes on the L. Oh, by the way, I'm an artist. I do like, I do a variety of things. So like, I do teach some stuff, like generally near the end of my courses. I do like a speed run of like teaching the course, if I have the energy to before my finals. And yeah, I like to visualize little creatures and things. Like that's why your handwriting is so beautiful, lol. Oh, well, so the funny thing is like, well, thank you, blushes. But they literally made us take a handwriting, like, they made us do handwriting homework like we were in kindergarten. Because, like, for engineering, there's, like, when you're doing drawings, like, for parts manufacturing, you have to do a certain kind of engineering lettering. And they literally make you, like, do handwriting exercises to, like, do these letters and have them be the right size, and you know, I'm not that good at it, but can you put a cool image of me up on screen? I have no images of you, Umbra. Like Laplace, Laplace is like a mysterious little guy. He kind of is just like this shady little creature. I don't know, I want him to be a circle, and I want him to have kind of like funny eyes. Oh, what if he's got like a big hat? Oh yeah, I'm enjoying that. He's like smirking. He's like, I'm about to solve this whole problem. I don't want him to have like a funny fedora. It's like not really a fedora. Maybe it's better that it's not a fedora. I feel like he's a little spy. I feel so cool when I do Laplace transforms. Maybe this is why I'm projecting. I don't know if I like the smirk. I feel like that's not a good enough character choice. He's got a grin. Oh yeah. His hat is like soggy. It's like falling over. Just sopping. His hat is just wet. I can't make his a wet hat. That's terrifying. I feel like he's kind of like a bug. Is he a bug? I've just drawn Ace Lacewing. Okay, it can't be a bug. I really just want to make a stag beetle guy, but like the other guy I made was kind of like a stag beetle guy. No, he's not a bug. He's not a bug. He'd be like very thin, like long. What if he's like, here, see? Oh no, what have I done? What have I done? Who is this? Who is this thing? I don't know if I like him. He just has maybe a little short coat, and then just long boots. Yeah, I don't hate that. I don't hate that. He's very like integrally. I like that a lot. I feel like he has a gun. Definitely. That's not a gun. We'll give him like a gun on his back. Like a secret spy agent. I like that anime eyeshadow, you know? Oh, I just ruined it. You can't see his eyes. There we go. Okay, I just need to make sure that I know this guy is the guy who I'm working with when I'm doing Laplace transforms, you know? Very important to me. Yeah, I like him. Oh, it's so cool. I realized my professor, like, actually does art, which is crazy because I've never had a professor who, like, does art. And he draws, like, these super sick, like, skeletons riding motorcycles. He's so cool. I'm like, dude, why have you not mentioned this before? Dude, I want to see these skeletons riding motorcycles, man. It's actually Friday. He looks like the guy, he looks like Snufkin. Oh my god, you're so right. What if I gave him, like, Moth? Oh, I don't hate that. Oh, wait, what if I give him integral antenna? Oh yeah, that's what we needed. Wait, I'll drown in a second. Wait, I am drowning. Whoops. Oh yeah. Okay, here, I'll sippy. He's so Snufkin. I like him. I'm sipping. I'm having a good sip. I think he would have like long little. Make him some long sleeves. Ooh, maybe he has like coattails. That'd be fun. Oh yeah. Oh, this guy is so real. I don't know, I just feel like there's a lot of differential concepts that are kind of like bugs to me. They're like on a small scale, you know? I need to be this Laplace transform. I'm so serious. This creature has so much gender energy. Can I be him? Yeah, I got you, Cosmo. Let me get you 1 second. I'm getting you in there. You're becoming him. There we go. Sorry, I committed a cardinal sin. There we go. You're there. Magic. Here, we can both be in there together. Here. What if we were in the Laplace integral as a convolution and we held hands? Sentences that are just insane to say. I DM'd you? What did you DM me, Umbra? Oh, a picture of you. This is just commonplace. I'm sorry. I'm sorry, Oak Spirit, for you having to find this out the hard way. Okay, so we need to Laplace transform Umbra. Here we go. The process begins. There you go. Your Laplace transform. I feel like that's what happens when you get like really shiny and like evil. Like your energy like becomes like an aura. That's what I think happens when you this is f of t. That's f of s. Big F of s. Does this make sense to anybody? Am I insane? Maybe I'm insane. It's okay, I don't mind being insane. Here's Umbra, by the way. I don't know why Umbra wanted me to put a picture of them up on screen. I love the Laplace. Dude, this little guy is so good. Wait, what if I gave him like little feetsies, like, wait a second, little funny feetsies. Oh my god, like he has little pants. Oh no, that's like... Oh, on the table? You put a picture of me up on screen? Big if true. Oh, in my background? No, I can't. That's like actual work. Oh my gosh, boots. There we go. All of the creatures just have high boots. A fucked up cat. So real. I really like him. All my creatures are every pronouns, by the way. That's pretty good. That's a pretty good Laplace transform. Okay. I'm glad we've done that. Now we can actually, like, do the Laplace transform. Yay! I'm just gonna A. We're gonna call it A over S squared plus 25 for this. Plus B over S squared plus 4. We're gonna have to, like, do... I actually don't even know if... Bottled? What? I don't know what that means. I don't actually know if I can do this like this. I think I might have to, like... I think it's gonna be AS plus B. And this one is BS plus C. Or no, sorry. CS plus D. Oh, bottled? Big water pronoun. Oh yeah. I was like, what is happening? What do you mean? Okay, I don't know. I can't take e to the negative s out of the transform. Okay, if I have e to the negative 7s inside the transform, we're putting it on the big S function. It's gonna turn into a unit step function. Okay, so unit step of 7. And then I'm not gonna do anything else. I'm gonna turn this into Laplace inverse of s minus 7. Okay, this has to be, like, wrong, I feel like, is the issue. Because if I do that, then I'm just gonna be, like, shifting it again. You know what I mean? And then, like, t goes to t... No, I don't. It's because that's the s. I'm not changing the t's. Okay, we're winning. Don't worry. T goes to t minus 7. It actually means we're gonna grind you into some sort of substance and put you in a small vial. If we drink Damie, we get his smartness. No. The smartness comes from osmosis. You guys don't get it. You guys need to believe in yourselves, and that's how you get the Damie smartness. You also just need to, like, be a little bit insane. I don't think drinking me would get my insanity, and being insane is how. We absorb all my deepest thoughts. Okay, I don't know if I mentioned this on stream. I like created a new part of my cosmology, like just my view of the world, where like I totally think that if multiverses exist, they have to be by translating in the fourth dimension. That's my deepest thought. What do you mean it's work? Drag the PNG. No, but why would I do that? No one else is in here. I can't just permanently have Umbra on my stream. Anyway, yeah, fourth dimension. You watched a wait, somebody else also thinks this? Wait, I literally just was thinking about this, and when I thought about it, I was like, oh my god, this is like so real. They say the other side of the on the other side of the black hole is another universe. What if I put all of chat on my on my lap? Absolutely crazy suggestions from chat today. I'm liking what Oak Spirit's talking about. If you follow Einstein's equations, they describe the plus axis. There might be another in the negative axis, his field equations. Okay, but that's if you go through a black hole. What I'm saying is if we translate over in the fourth dimension, you end up in an entirely new space of 3D objects. Some of which could be the same, but some of which could be different. Our whole universe is in the plus axis. It's by going through the fourth dimension? Oh, I see. So there's only one place. Oh. I feel like Einstein didn't even actually exist. He was just like really cool. Okay, if Einstein didn't exist, then like, who would have done all that stuff? Just like a collection of people? How is that more believable, like, or less believable than just one guy doing it? I feel like they're both the same believability. No, but each universe has another universe attached to it, so theoretically infinite. Oh, okay. But also, like, there can be multiple black holes, right? So it's like just a choose your own adventure. You just go through this one, it's like, oh, I'm here, and then it's like, oh, there's a lot here, so I go this way. That'd be kind of cool. Each black hole is another, yeah. That is pretty sick. I like that. The reason I don't like that is because I'm like, man, it'd be so far to walk to a black hole. That doesn't mean anybody can access another multiverse. It's a really funny reason to think of it like that. And for my toilet interpretation, I could just be like, yeah, shit's kind of relative in it. Yeah, but he like proved it. The atomic clock. You know? That's how they prove that stuff. Veritasium video? Oh yeah. No, I know, he just made theories. I read it. I didn't read it out loud, but I did read it. I don't like this. What is this? S squared plus 4? Okay, this one we can do. I don't want to do that. This one is scary. This FO one is scary. If it's AS... This one we actually have to decompose to do this. Let's just do it. Yeah, I mean, yeah, we couldn't know anything is real. We could also be living in a simulation, but like, where does that get us? Like, if we're living in a simulation, does that somehow change the fact that you still want to know about the known universe? Like, that's what I don't understand about simulation people. It's like, cool, sure, we could be. I'm down. What now? So we have a times s squared plus 4, and then plus... Nope, I lied. A plus... as plus b, times s squared plus 4. Plus cs plus d, s squared plus 25. Gotta hack the vulnerability in the code. You gotta find the vulnerability in the code and hack out. What if the world out there sucks, though? What happens if it's like, you know in that one Adventure Time episode, the Egg and Me Adventure Time episode, where they find all those, in the miniseries, they find all those humans who have just been living in, like, this alternate dimension, like, multiverse, like, reality place, and they're like, dude, it sucks out here because it's the apocalypse. Then L. They're like, no, we just want to go back because, like, our bodies are, like, decrepit and dying, and, like, we don't have to worry about food or anything in this, like, fun, epic world. Except this world is capitalism, so maybe it's not that great. I don't know. I feel like There's so many cool things about our world that are already fun and weird and interesting that it's like I don't need to like worry about what's beyond that. Why did I say 0? That doesn't equal 0. That equals S. Cameras proper were made in 1888. Mr. Stein died, and you're telling me about no pictures of the... Wait, we have pictures of Einstein. Oh my god. Okay, what am I saying? As a girl with chronic derealization, my philosophy for simulation theory is that no matter what is real or fake, love will always be real. There is some kind of simulation that tried to elicit specific reactions from humans for research. Feel love would be way too hard to code in. So real. We have pictures of him as a kid. I know, what is this like? We don't have pictures of Einstein. This is just wrong. Show me a real image of Einstein. They're literally like just regular images of him like teaching lectures. Einstein pictures. He's just some guy. Like, I mean, he's not just some guy. But like, look at this. Here's a real picture of him. This is like about as real a picture you can get. This is like somebody just took this on their like camera phone. They all look so fake. I don't know, this one looks pretty real to me. I'm Einstein, actually. It was this one that Oak Spirit showed. Is it like the image? Yeah, this is a real image of Einstein too. Yeah, this is what he looked like. That looks like you took it to... What? Why? I don't understand why you would put energy into thinking he doesn't exist. There's no way you can prove he does or doesn't exist, I guess, if you really want to fake Einstein theory. What does that achieve? What, you want to call like his laws something else? You want to call them by a different person's name? Like, the laws still exist. We proved the laws. I'm kind of like going insane over this. That's a wild theory. I mean, Einstein's laws are like some of the coolest laws of the thing. How do we even know those are real? Because we did experiments and we observed them being real. Proved by who? The people who... Okay. Relativity... Atomic clock experiment. In one landmark... Let me see. Let me get a better... Here, look. National Institution of Standards and Technology. Physicists have measured Einstein's theory of general relativity, time dilation at the small scale, showing that two atomic tiny clocks separated by just a millimeter tick at different rates. There we go. Go do it yourself. Here you go. Here's an official website. Okay, it's the US, so, you know, take that with a grain of salt. But there you go. There's your proof. Some guy did it. Yeah, because the thing is, when you like do math and you like understand these things about relationships and you just like go off into that space and you like know all this stuff, you find out a bunch of stuff because you just like keep searching for it and you're alive for such a long time that like you always find new stuff. Like my Pookie Bear. Hi Clem. How's it going? How are you on this fine day? It's Friday. Oh, are we gonna drown me again? I'm down. I'm down for a secondary drowning. This is a weird system. Oh god. Oh no. I don't have enough voids. Yes! Thank god, I've been saved by the bell. Oh wait, do you wanna look at this little guy we made? That's the Laplace transform. I'm gonna put this on there for my grader to see. Yay! OMG. Taking some sips. That's such a cute little guy. Umbra believes that Einstein didn't exist. That's what we're talking about right now. I can't do anything on Twitch, it won't let me drown. I think Firefox broke all the shit. No, I'm so sad. I really wish Firefox had better user profiles because I switched browsers. Like, for this one, and it's on Chromium, and I really don't want to use Chromium, but like, it's such a cool such a cool browser, and I really want to use Firefox, but the profiles are so bad. 90k points. Oh my god, biggest Damie fan here. Oh, I have to do the ASMR textbook reading still. I should put that on the schedule. Drink all those drinks. Now, I'm drinking them. Wait a second. Here, I'll put on the toggle even. These are eating the string your browser sees it sends a figure. Like Google is blocking it from capture or something? Weird. Ugh. Oh, there we go. It's gonna become a conspiracy. What is? Einstein didn't exist? I don't... Dude. I guess my answer is like, who cares? Like, that's so much of like what I think about like many conspiracies. I'm like, who cares? Google's trying to break Firefox. There are some, there are extensions you can get that help trick Google into not thinking you are on Firefox, by the way. You might have already found them. I'm sure you're like based as hell. But wait, I need a 4x5, not a... There's my 4x5. God damn it, I meant to edit it. Here we go. 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 4, 0, 25. What if I just do this later? Let's do it later. I don't want to do constants. That's boring. Get to some meat. Oh wait, we can do convolution. Oh wait, poggers, let's go. I didn't think we were gonna get it there. Okay. F convoluted with G of t, where f of t equals t squared and g of t equals t cubed. Okay, so our general form for our convolution is going to be 0 to t of t minus tau. So this is our f of t minus tau, t minus tau squared, times tau cubed, d tau. Okay, now how do we integrate this? Integration by parts. Okay, we're fine. So t minus tau squared, tau cubed. Ooh, here we go. So 1/3 tau to the 4th, 1/12 tau to the 5th, 1/60th tau to the 6th. Yeah, and then that's probably enough. And then we get negative t minus tau. Yeah, no, yes, no, negative 2. And then just 2. And then 0. So positive, negative, positive. Oh yeah. So this equals... Wait, is it? It's d tau. Yeah. So we'll get... I guess I could pull a tau cubed out of everything. Or tau to the 4th out of everything. So we get t minus tau squared over 3 minus 1 over 2 over 12 tau t minus tau plus 2 over 60. tau squared. There we go. Hope you enjoyed reading my essay as much as I did writing it. What about Einstein? Oh, from 0 to t. Okay, so when we have t, it's gonna be t to the 4th times, those both go to 0, so 1/30 t squared minus, well, it's just gonna be 0, right? Ooh, poggers. Can we get a big omega lol in chat? I don't know. I think that's right. Maybe, I don't know. It's so weird doing like math or something on stream because it's like, I don't know. I'm sorry. I'm just like some guy. Most people like come on here and they're like, yeah, I know what I'm doing. And then I'm over here doing my like, I think it's so funny when people come in and say like, do harder math. You ever finished a math problem and broke a smile? Oh my god, there's so many times. Yeah. Yes. Every time. After 3 pages of sweat, tears, and notebook paper, there was one I did in my intro to differential equations class, or like my linear 1 here. It was an annihilator problem. I don't know if you guys have done that method, but it's like sort of like choosing you choose like an annihilator function and then you like do all the derivatives and stuff. It was like sines, cosines. It was so long. It was like a half-hour problem if you did it like fast, and it was taking me so long. And I was yes. It's an awesome name. It is an awesome name. Unfortunately, it is not an awesome process. It's very long and also very inefficient. Minuscule lol. You get a small omega lol. Only small laughs, okay guys? Only the most prestigious, smallest laughs in my chat. We have to have a sensible chuckle at things. We can't laugh. We can't. That's for peasants. That's for that's for linear 1 students. I'm allowed to chortle a teehee? No. No. Chortle is slightly too rowdy. Oh, ehehe, ahaha, too. Ahaha, too much. Mike Demon's gonna come and get you. Ooh, we get to do convolution integral. I love it. Convolution integrals are so fast. They're so sick. They're so awesome. I don't know what this is. F of s. Okay, big F of s equals s plus 1 over s plus s squared plus 2s plus 2. It has to be quieter. Your Mike Demon is in love with me. He would never. Whoa. He is in love with you. Oh, he just wrote s, but I think he meant to write g of s like that. Equals 1 over s plus 3 squared. Why do you keep saying ass? S? G of ass? It's my S. It's my accent. I don't know. I'm from the East Coast. S. If you guys say ass like S, I got to go play content warning. I have no real excuse. I just need content warning. Yeah, no worries. Have fun. I'm saying S like what are you talking about? G of S. Wait, I want to play content warning too. I'm addicted. I'll have to try sometime. I don't have it. I gotta get it. Completely set up the integral, but do not evaluate it. Okay. Laplace inverse of f of s times g. Okay. So the thing about Laplaces is you're not allowed to say this does not equal the Laplace of f times the Laplace of g. That is illegal, but it does equal something. I missed when it was free. I know. I know. The Indian circuits. Oh my god, yeah, dude. I will say, if you need to solve a problem and you find some wonderful, sweet, kind Indian man who has a very thick accent, you're going to find exactly what you need on that YouTube video. There's just some like wonderful like energy in the universe that just brings the answers that you need to those kind of people. They know what to do. That's so true. Watching those videos reminds me of sleep paralysis demon. That's so funny. I remember, I think I watched like a video by some guy like that who was doing them on like this more complicated version of limits, like epsilon definition of limits, and I was like, wow, this is the best explained thing ever. It was great. What was I getting? Oh, convolution of S. Yeah, of, not S, of f of t, g of t, right here. I did a winky face in my notes. Where is it? Nope, that's not it. Nope, it is it. What is this? Oh, I had to learn epsilon delta. I never had to actually learn those. Teehee. Wait, what about Laplace of f convolution g? What about Laplace inverse of f convolution? We did not do that. So the Laplace of little f. Okay, so the inverse Laplace is going to equal f convolution of g. Cool. So like this. So little f but I need to know what little oh, I guess I have to turn these into their functions then, and then I can do the convolution? Yeah. Well, this sucks. I hate this. Wait, no. Wait, yeah. Yeah, I do hate that. Okay, I'm not gonna do the partial fraction decomposition. But that's what this is. We're just gonna... We do the partial fraction decomposition. This one I don't actually... Do I have to complete the square for this one? I think... Oh wait, this one's not too bad. This one will be s plus 1 plus 1, and then I'll take s plus 1, and then it'll be 1, and then, yeah, I'll have to do some extra... It'll be square root of 2. But that won't be too bad. Oh, I can do f of... Okay, so f of s equals... I guess I should do, like, the inverse Laplace of that. That's going to be s plus 1 over s squared plus 2s plus 1 plus... Oh, plus 1! Oh, poggers, never mind. We're all good. Okay, I forgot the Laplace. You can tell I'm just getting, like, more and more... Oh my god, it's 4:38? Oh, I gotta stop soon. I have a thing at 5. It's okay. I do have my schedule up, though. Wait, I should, like, make a thing for my schedule. I didn't do that. At least I posted it in the Discord. Okay, so this is gonna be s plus 1... Wait, do I have to No. I can't have it be plus 0. What's up with that? What's up with that? S squared plus 2s plus 2. 2 is not going to equal 2 unless we want to have an I in there. We don't want to have an I in there. For sure. So we want to complete the square. But... if I have s plus 1, it's going to be 0 on the sign. Oh wait, yeah, of course it's going to be 0 on the sign. That's just the definition of cosine of... Oh my god, that's the definition of t cosine t times e to the negative, e to the s t. E to the negative, e to the st. 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 E to the negative, Wait, no, e to the t. That's so funny. I was like, why is it 0 on the sign? I don't know. It's literally just cosine. That's funny. Yeah, that's nice though. And then we'll just have to do that. I mean, it's going to be a big partial fraction limit. But, oh wait, no, it says just set it up. Easy. Easy. I guess we could do, maybe we could do the partial fraction. We need to set up a partial fraction for g of s. That would be loss inverse of g of s equals Laplace inverse of, why did I do it like that? Oh, I guess I could do whatever. S plus 3, or A, S plus 3 plus B, S plus C over S plus 3. I have to check that that's the right way to do that. I feel like it's not. All the people in the comments going, can't believe he didn't know how to do the partial fraction decomposition. I can't even believe he has this video up. It's okay. Didn't get to do any fluids. That's a little sad. But hey, it was pretty good. We got almost all the way to the end. We actually almost did most of the 8 problems, which is kind of crazy. I'm gonna clean this up tomorrow. I mean, yeah, I probably won't stream tomorrow because I have my thing I have a thing, basically I'm busy from like, I'm busy till like 2, and then I normally wouldn't start streaming that late. Maybe I will. I don't know. Maybe keep an ear out for that in the Discord. I do ping in the Discord. Let me put my schedule up on the stream real quick. Let me show. Here we go. So this Sunday, me and Clem and Rev and maybe Cosmo too are gonna do something art. Monday we're gonna do fluid dynamics, and then Wednesday we might do some linear. I don't know. But I'm gonna try and do linear tomorrow, like off stream stuff. So yeah, that's the deal. And then I'm hoping VODs come out on the opposite days. So like Tuesday there'll be a VOD, Thursday there'll be a VOD, and then this Sunday is like this Sunday. So hopefully I think tomorrow there'll be a VOD. I'm gonna try and do like what's the word? Like alternating VODs and streams. Because we are behind on uploading my VODs, oh my god. If you want to see my VODs, like I have my linear 1 up, I think, by now. Maybe? Yeah, I definitely have my linear 1 up by now. So if you are interested in that, or you want to see other stuff I'm doing, then it's over my VODs channel. Yeah, I think I gotta head out now. Keep an eye on, I don't know, I should make a bot command for like when the next stream is, but that would like, I would have to update it and I would never update it. But yeah, I will be around. Thanks so much for hanging out, guys. It's nice meeting you, Oak Spirit. I don't know if you're still here, but hi, it's nice. And yeah, have a nice day. Eat some good food. And I will see you guys on Sunday, if not tomorrow. Maybe not tomorrow. Like, there's a 50% chance. I have to like do mate and stuff as well. All right. See ya.